All right. So mathematicians appreciate brevity, and the indefinite integral is what we have shown right here. It is some notation that's asking us to find the general antiderivative. So that purple kind of swoop ds partnered with those dx's, we'll get used to that and we'll talk about why that's good notation later, but right now we're just getting practice at reading this. When I see that purple, it's supposed to provoke in me a question. The derivative of what function is the one that they're showing right here? The derivative of what function is green? Well, the derivative of big capital F, the derivative of yellow is green because it's an antiderivative. Moreover, the derivative of yellow plus any constant is green, right? So this is true since if you take the derivative of your antiderivative function, if I take the derivative of yellow plus any constant, I get green plus 0. Well, green plus 0 is just green, right? So we've asked you to do this before by finding that general antiderivative. Go find big capital F of x plus c, right? And we give you the function f of x. Or I could say in English, find that indefinite integral of f of x. That's how we read this. Find the indefinite integral of f of x. Both of these questions are asking the same thing. They're asking us to find that f of x plus c. They're asking us to find the function, specifically the family of functions, such that when we take their derivative, so whose derivative is f of x. That's an is. Okay. So we're just going to get some traction with reading these questions, right? Because in the past we've given it all to you in words. I'm going to go ahead and do it with you in words, but we want to transition to just looking at that notation and knowing what question it's asking me, what family of functions it's asking me to find. Okay? So, moving in the forward direction, in the differentiation direction, the derivative of x to the fifth is 5x to the fourth. So, x to the fifth plus any constant is a general antiderivative of what? Of 5x to the fourth. Why? Because when I take the derivative of my antiderivative, of my general antiderivative, I get f of x. When I take the derivative of yellow plus orange, I get green plus 0, which is green. All right? So we have been asking you to go backwards, right? Undifferentiate. We've been asking you to do that with this language. Find the general antiderivative, right? Go find the general antiderivative, and we specifically name the function 5x to the fourth. What we want to now transition to is seeing this set of symbols here in purple, this indefinite integral with that dx, those two things go together. That is supposed to provoke in me a question. The derivative of what function is the function we're showing you here? Well, the derivative of yellow plus orange is green plus 0, which is just green. Yeah? Let's just do, I've got a handful more. I'm just getting some traction with this reading. Right? The derivative of x to the 5th divided by 5 would be 5/5 x to the 4th, which is just x to the 4th. So x to the 5th plus c is our general antiderivative of x to the 4th. Right? Moving in the differentiation direction is definitely more comfortable. I've asked you to undifferentiate up until this point by prompting you this way. Find the general antiderivative. Find the family of functions whose derivative is what? Whose derivative is x to the 4th. And you've gone ahead and practiced working backwards. What's new now is reading this set of symbols. This general antiderivative is asking me, that's true. General antiderivatives and indefinite integrals are the exact same thing, right? Or they're asking you to find the same function. Go ahead and find this. I apologize for my misspeak. Right, so the purple is asking me what? The derivative of what function is the one that they're showing us right here. The derivative of what function is x to the 4th. Well, you do your work working backwards and you say the derivative of x to the 5th divided by 5 plus any constant will be x to the 4th. The derivative of yellow plus orange is green plus 0, which is just green. A few more. The derivative of tangent is secant squared. So tangent x plus any constant would be the general antiderivative of what function? Of secant squared. Right? Going backwards, find the general antiderivative of secant squared. We've been asking you that just straight up in English. Find the general antiderivative of secant squared, and you would be asking yourself, well, the derivative of what function is secant squared? Oh, the derivative of tangent is secant squared, so the derivative of tangent plus any constant will be secant squared. Instead of doing this question and answer this way, we're learning this indefinite integral notation. Those sets of symbols that I just highlighted in purple are provoking in me a question. The derivative of what function is the one that we're showing you here? The derivative of what function is secant squared? Oh, the derivative of tangent is secant squared. And moreover, the derivative of tangent plus any constant is secant squared. Okay? Just one more. The derivative of secant is secant x times tangent x. Then secant x plus c is got to be the general antiderivative of what function? Of secant times tangent. All right? We've been asking you to undifferentiate. We've been asking you to work backwards by writing this in English. Find the general antiderivative of secant times tangent. A much more concise way for us to ask you that question is with this indefinite integral notation. The purple that I just highlighted provokes in us a question. The derivative of what function is the function that they're showing us right here? The derivative of what function is secant times tangent? Well, the derivative of secant is secant times tangent. Moreover, the derivative of secant plus any constant is secant times tangent. Okay? Anytime you learn new notation, initially it feels real strange, but I think you can see that there is virtue in having a nice, concise way for us to ask you to undifferentiate. And we'll later start calling that integrate. All right. This concludes the video. Thank you for watching.